Hey, let's do one more example of given a graph. Okay, given a graph of trig modeling, we have to get the equation and maybe get some further information out of it. Let's take a look here. Okay, so we have three graphs. First job is to determine the equation of the three different graphs here. So let's do one first. Okay, so they're all in the middle. The equation of the axis is y is equal to 12. So they're all going to have a vertical shift of 12. Okay, let's get some information here. Let's get the amplitude is from 12 to, what is that, 22? That's exactly 10. So amplitude is 10 for all of them. Okay, and then this one is starting from the origin, so no phase shift. And then the period, right, is way at the bottom here. So the period is 0.15. So period is 360 divided by k is 0.15. So k is going to be 360 divided by 0.15. Okay. Okay, so when I got that, I got 2400. All right, we're ready to write the first one. So y is going to be, amplitude is 10. It's a sine function. K is 2400, and then it's x. Okay, and there is one more thing, vertical, right? Vertical shift of 12. All right, let's do the second one. Second one, let's start from, what is this? This is that, okay. So that starts from there, or we can start from there. Either way, we need to figure out this length here, okay, which is going to be exactly 1/3 of that, okay? So let me just write that out. The phase shift is going to be, we're going to 1, 2, 3, 4, right? Exactly 4 is a sine function. So we can do y 10 sine. K we need to find, but x is going to be, we're going to be moving that 0.0375 divide by 3 to get one of these length, and then I'm going to times it by 4 to get to that exact spot right there. Okay, you can plug that into a calculator and get the number, but okay, that's the correct phase shift, and then plus 12. Okay, what's missing? We are missing the period. Okay, so from all right, so clearly a quarter of the period. Okay, quarter of the period is the difference between, it's exactly going to be 3 times this. That's exactly this, 0.0375. So the period is 4 times 0.0375. And then K, okay, go back to here, is 360 over K is, okay, 375, okay. All right, one more step. K is then 360 over 4 times 0.0375. All that work, the period is exactly the same. In fact, I think they all have the same period. I just wanted to verify they weren't off by a little bit. Okay, the three graphs have the same period. So that means we have our equation. We just have this to be 2400, just like that one. Let's evaluate that. I get that, 0.05. Okay, 0.05 plus 12. Okay, and then lastly, the third one, it starts right there. And yeah, so it starts right there. So we can use y is equal to minus 10, the sign, because we're going bottom, right? It's gonna be the same 2400, the period is the same. And the shift is going to be x minus this, right? This was the length of exactly that one square, edge of the square there. So we just gotta, we went twice, so just times that by 2, 0.0375 times by 2 divided by 3, okay? And I get 0.025, okay? All right, determine the frequency of the motion. So they all have the same frequency because they all have the same period. Frequency is 1 over the period. So 1 over the period was this, right? 0.15. Okay, I get 6.67. Okay, so it's 6.67 cycles per, I think the time is in seconds. So that's the frequency, okay? All right, so that was another one where we have to observe the graph and get all the information to get our equation that models the motion. That's it for this one. I'll see you in the next.